So let's start. Hey everyone, my name is Alex. I'm a developer at Quex, and today I'll tell you about our product and how you can use it in your hackathon projects. Moment. Yeah. What question I want to cover today? First one, what Quex is. Second, what is trust execution environment? The technology we utilize to build our solutions. And next one, how can Quex be useful in your projects? And I show you an example of its usage. Let's briefly start with what Quex is. Quex is data transfer layer for Web3 solutions. It's based on trust execution environment technology, about which I will talk later. Two main cases of use Quex is when you need to get an external data or you need to perform some heavy computations. Let's start with, let's continue with what trust execution environment is. TE is hardware isolated environment which primarily designed for perform secure computation over sensitive data. Two main things you need to know about TE. It ensure that no one, even host owner, that even privileged user on the host couldn't interfere the execution process and couldn't get any sensitive data from this environment. And when you communicate with this secure environment, you can be you can ensure that you can communicate with secure environment by procedure called remote attestation. You provide signed report of this environment and get information about code inside and stuff like this, and it's provide full chain of trust to some root certificate from vendor. T is not theory things. It's has lots of usages in real-world applications. Everyone has mobile phones, and all biometrical data when we use our fingerprints to unlock our phones or use Face ID on Apple. All this computation performed inside trust execution environment. Second case where it can be useful, it's confidential AI inference. You can, it helps to protect both model and input data. It can be helpful in cases like healthcare data, where data is really sensitive and protected by government, by law. Confidential cloud computing, so you can run sensitive workloads on untrusted infrastructure. And what we do in Quex with this technology, we create oracles for Web3 solutions to provide verifiable off-chain computation and to provide also secure data transfer. Compared to other Oracle solutions, with Quex, you need only one server to execute something. You don't need some consensus mechanism, or if compared to zero-knowledge proofs, it's much faster. Its execution time almost the same as outside of trust execution environment. So it's pretty fast and it provides trust minimized result, trust minimized execution. In Quex, we utilize nowadays pretty modern technology called Intel Trust Domain Extension. Compared to previous trust execution environment solutions, this runs at virtual machine level, so it allows run whole virtual machine, not some application. And what this provides to us, we can run any legacy application inside inside TDX. We have full OS operation system support, so richer tooling, better compatibility, and to wrap this up, it makes trust execution environments practical for real world workloads. And next question I want to cover is why Quex? Today I'll talk about one possible usage of Quex. It's about calling HTTPS APIs. And with Quex, you can call any HTTPS API, not some pre-approved feeds or hand-picked endpoints. You can even call a credential protected API because you can encrypt secrets, and only particular instance of TDX will be able to decrypt this data, and by design this data won't be leaked in any way. So you can get relevant clean data which is ready to use on chain. So lots of Web2 APIs designed for front-end, not for smart contracts. Usually it provides deeply nested JSON objects, and your smart contracts probably need only one or two fields from this. And with GQ processing language, we provide opportunity to format this data in the way you need in your smart contracts. And we also provide on-demand or pool-based models, so request callback model, where you can ask for data whenever you need it, not wasting gas for some periodical delivery of the data. And let's have a look at some example and get more familiar with Quex through this. Let's imagine that for your product, you need to get current Ethereum price and its change for the last 24 hours. To understand how to tackle this problem, let's firstly have a look at request lifecycle in Quex. So user or the app defines request specification and create request. Then relaying services of chain gets that particular request and put it into trusted domain, the instance of TE that securely processes this data. So trusted domain, call external API, receive response, transform this response in a way you need it, and pack it with ABI encoding, put this data, and sign this data, which is most valuable part here. Then return this data to relay and service, which puts data back to Quex contracts. And Quex contracts verify this signage, verify that that particular trusted domain was authorized to perform this type of requests, and returns data to your the app. So having this request cycle in mind, we can think of 4 steps that we have to perform to solve our problem. First one, we need to define the data source. We need to get Ethereum price and its change for the last 24 hours. One of the ways to get this data, we can use CoinGecko API request we can see on the screen right now. So what's interesting here? We have few query parameters. We have a few headers, one of which contains sensitive data. It's CoinGecko API key. From this API, we expect to get response like this. So it's an object containing one field, Ethereum, and which is an object also containing 2 fields, price and price change. In this way, it's not useful. It's not worth it to return data in this way to back on chain. We need to transform this data to be more suitable for on-chain processing. For this, we can use GQ. Let's have a look at some simple example of GQ filter. So we take field Ethereum, and we'll get here object of price and its change. And we create from that particular object array of 2 values, price and price change. We, after applying this GQ filter to our response, we will get the following array. It's an array of 2 floating numbers. In this way, we also can't move it back on chain, because on chain we can work only with integer numbers. So let's modify our GQ a little bit, add multipliers and rounding. And after this change, we can get an array of 2 integers. So we completed our first part. We understand which request we want to make. We understand how post-process this response. And we know which data we get back on chain after this processing. So let's move further and configure request specification and response callback in Quex. In Quex, combination of request itself, post-processing, and a callback, we call flow. Our library provides flow builder. You need to specify 2 addresses of Quex core and request oracle pool. First contract responsible for storing routing information and verifying responses. Second, responsible for storing configuration of requests. We also need to provide host and endpoint of our API, and we said that it's a get method. Then we need to add our query parameters. We had 3 of them. One is Ethereum, so we want price of Ethereum to USD, and we also want to include price change in our response. And we add in these query parameters to our flow builder. The same thing with header, which doesn't contain sensitive data. We create a header and add it to our flow builder. A little bit more complicated with sensitive data. So our API key to CoinGecko. Firstly, we need to encrypt this data with trust domain public key. This public key can be found in our documentation, and as well as addresses of Quex contracts and Oracle pool contracts I mentioned before. So we encrypt this and add to our flow builder. Also, it's possible to add encrypted query parameters, encrypted body, and encrypted path suffix. So at this point, we finished to transform all our requests to this code. We defined path, we defined endpoint, we defined get method, query parameters, and headers. Then we need to specify a filter. Filter was shown before. And we need to provide schema. So in our case, we expect to get back a tuple of 2 integers. So it's shown here. And next part, we need to say where to put data back. So you need to provide your callback contract and your callback function, and specify gas limit for this callback. So at these steps, we finished with configuring request specification. Oh, let me get back for one moment. As a result, we receive flow ID. This flow ID is reusable if you need to perform a particular request multiple times. Or you can create flow IDs anytime you need to perform request. Both options are okay. So let's move to the next part. It's creating request. To create request, firstly, you need to get request fee. Request fee contains of 2 parts, price in native tokens and price in gas fee, mostly contains of gas limit for callback you provided on the previous state. And we need to calculate full request fee. It's sum of native fee and gas fee multiplied by current gas price. We need to create request, put value for this, and provide that we need to create a request with particular flow ID. We also need to store some context of this request to be able to continue process of our of solving our problem. So in this particular case, it's just some action ID related to this request, but it could be some different things too. And let's move to the last part of this usage example. We need to process result. As a result, we will receive request ID, we will receive response, and we will receive ID type. In our case, it will be a request ID because we use here request callback model. Firstly, we need to ensure that this message sender is Quex to be sure that data verified and you can trust them. Then you need to retrieve your request context, ensure that you know about this request and how to process it. And you need to decode response value with tuple of two integers we specified before. So we receive our price and we receive its change for last 24 hours. And you need to perform some logic that you, for what you requested this data. So that's it about our example. Let's move further. Oh yeah, our bound slide. Marketing insisted that I have to read it aloud. I resisted, I lost, so let's do it. For the first, so we have three prices. For the first place, we'll be awarded with 1,500 of Quex credits. Second prize with 1,000, and third prize will be 500. So yeah, and winners may have a chance to share their project to the Quex media resources. We also invite winners to co-marketing opportunities, posts, streams, AMA session, etc. And let's have in touch and questions. Okay. Yes. Yeah. Yeah. Yes, it's a library that we provide in our interface repository. Okay, right now we provide only options to communicate with HTTP requests, but what I didn't say here to make it a little bit more simple, Quex is not only one oracle, it's also the platform. You can run some your code inside trust execution environment and move all logic about verification of the result to Quex, and you can also come to us. Maybe you have some interesting ideas what interesting can be built on these technologies, and maybe gRPC is also the case, what to do. It could be, I don't know, running AI models, it could be some heavy computations, so you can get lots of data from on-chain and process this. It's not necessary HTTP requests, but right now we focused on, we provide only one example of this, how to use this technology. In few. Yeah. Actually, no, nothing was deployed before. So you create on-chain whole specification of the of your request. So you provide. Let me move a little bit. Yeah. So GQ is processing language. So you let me move to GQ part. So what's written here? I need some Ethereum. I need to create an array of two objects, Ethereum USD and Ethereum USD 24-hour change. Uh, mm, so GQ provides lots of options to how you can transform your JSON. We support subsequence of this because GQ provides a little bit more than we want. For example, you can get environment variables from this. It's not good to do it fully, to support it fully, so it's a language how you transform your JSON. Yeah. Yeah. Okay. Okay. One moment. So yeah, here here an example. Filter is GQ is pretty big. I didn't specify this. So you when you create flow, you provide also GQ you want to execute on. Yeah, right now so it's HTTPS request with GQ post-processing and IB encoding. But once again, if you have some ideas of what else can be done on TE technology, you can wrap this into virtual machine and it can be run on this technology. Right now, yes. But on this technology, different parties could be participate. Um, Intel, we support only Intel TEDx. It's yeah, you get reports, register this trust domain inside our solution and show that to the world I use Quex. So to configure your request, you need not some HTTPS request, but some other dates. So yeah, it's possible. Yeah, it's also possible that so you run your own Oracle pool and you have a monetization option. So Quex will initially reserve fund for request, and then you get some part of this. Welcome. So any other question? Oh, we ran after you. Yeah. Okay. So thank you. Thank you once again.